Okay, girls, so we're going to start today with our lesson on Pythagoras Theorem. Before we get into it, let's just remember what can we classify triangles. So triangles can be classified by either side length of the triangles or its internal angles. If we classify it by side length, we will have an equilateral triangle, which means that all sizes are the same. We can have an isosceles triangle, which means that two sides of the triangle are the same, and escalene triangle, which means that none of its sides measure the same. If we classify triangles by its angles, then we have also three types. We can have an acute triangle, which means that all the internal angles of that triangle are acute, or that they measure less than 90 degrees. We can also have an obtuse triangle, which means that one of the internal angles is more than 90 degrees or obtuse, and a right angle triangle, which means that it has one angle that measures exactly 90 degrees, one right angle. Okay, well, I'm not going to draw all these triangles because that takes a long time, but here we have our right angle triangle. Usually when we have a right angle triangle, they show us which one, or is indicated which one is the right angle. And in this case we can see, let's use this one. In this case we can see that here they're pointing out to say that here we have our right angle triangle. Perfect. Now just to remember this, remember that in all triangles the longest side is opposite to the largest angle. So in this case, what we can see, we have here our right angle triangle, and we can see that the other two angles are acute, which means that both of them are less than 90 degrees. So this one is my largest angle, and therefore this opposite side is going to be my largest or my longest side. Okay, so if we focus, now I have here my right angle triangle bigger, and what I was saying before, you can see here they're indicating that here I have my right angle triangle, which is exactly 90 degrees, and the opposite side, which is this long purple or pink or fuchsia, or I don't know how to call this color, is the longest side of this triangle. This longest side has an important name, and the name is called the hypotenuse. And the hypotenuse, as we said before, is the longest side of a right angle triangle, and is always, 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 always opposite to the right angle. So we have to remember this. And how do we identify it very quickly? When we have a right angle triangle, we identify where is our right angle triangle, and the opposite side is going to be our hypotenuse. Okay, I forgot to mention before, but in this unit of Pythagoras theorem and trigonometry, we're only going to be working with right angle triangles. So that's why when we were talking just before here about how can we classify triangles, I just want us to focus on these right angle triangles. Okay, fantastic. Now, one more thing here. If we, here we have our same right angle triangle, and I just want us, we're going to put names to these three sides. And this is convention. We use the same variables or pronumerals to name these sides, and it's just convention in maths. So the hypotenuse is always going to be named C. Okay, so once we have identified our right angle in our triangle, the opposite side is going to be C. And then the other two shorter sides are going to be called A and B. It really doesn't matter which one is A and which one is B, as long as you are consistent, that if you called in one exercise this side A, it continues to be A for the whole problem. But it doesn't matter which one do you pick here. Okay, I'm going to stop here and see how's it going, and then I'll continue with another video. Our videos. So hopefully we will have time in class to do this activity. So I just want to show you what you're going to be doing and how this activity is going to be related to Pythagoras theorem. So we have here our right angle triangle, and we have labeled it as we say that we were to, so with the conventions that we already spoken about. So we have our right angle here, therefore my opposite side is going to be my longest side, and is what we call C, and we call it hypotenuse, and the shorter sides, this one I called it B here and A in this case. Perfect. So what I'm going to do is I'm going to draw, but I'm not actually going to do it. I'm going to use the computer because I can't draw for my life. But if I do a square here with this side, so I'm going to create a square here with this side length, which means that if I'm going to do a square, this length has to be also be C, and then C, and then C, and then I'll have that square. Let's see if this works. Perfect. So I have my square there. You can see it here. And I know that this side is C. If I want to know what is the area of this square, what it will be, so I'm hoping that you're answering. So it's going to be C times C, which is C square. I just need a pen. Give me a pen here. So this one is going to be C square. Perfect. There you go. We have our C square there. Now, I did the same thing on this shorter side. As you can tell, I drew another square, and this one has length of B, 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 and B, and therefore the area of this square is going to be B square. Perfect. And if I do the same here on the other shorter side, we will have then A square. Agree? So there we go. We have our right angle triangle. This is not perfect. Please forgive me. I'm using PowerPoint. I'm not using like a very sophisticated drawing software. So you can see here that is not actually 100%, but what you are going to be doing in this activity, what we want you to do is you're going to be doing these squares, and you're going to do it in paper, in color paper, and you're going to do it perfectly. And then you will see that the area of this big square that we have here, which was formed by the hypotenuse C square, is going to be equal to A square plus B square. So if we cut these two, this square, we place it here, and we cut this square in certain way, we are able to fix it in here and see that it matches perfectly. So basically what you're going to come up with is that A square plus B square equals C square. And this is what is called the Pythagoras theorem. The Pythagoras theorem establishes the relationship between the length of the sides of a right angled triangle. It's important to notice here that any right angled triangle will follow this theorem. And what is the theorem? Exactly what we established just before. So it's going to say that our hypotenuse, that we by convention use the pronumeral C, so C square. So the square of our hypotenuse is going to be equal to the square of the shorter side, which we say A square plus B square. Fantastic. And this is going to be our theorem. Okay, this is our theorem. This is Pythagoras' theorem. Now, this is useful if we need to find our hypotenuse length. But sometimes they're going to ask us to find one of the shorter sides. So what happens if we have to do that? So if we have to do that, what can we do? So if we have c squared equals a squared plus b squared, let's say that I have to find a. So if I have to find a, what can I do? I can subtract both sides this term of b squared. So let's do it with, I'm going to do it with this right one. So I'm going to say minus b squared on this side, and I do the same thing on the other side, minus b squared. And I get c squared minus b squared, it's equal to e squared. I just want to rearrange this. I'm just going to write it as a squared equals c squared minus b squared, only because it looks nicer and is more clear. So if I do a squared, it's going to be equal to c squared minus b squared. So this is also very useful if we have to find the shorter side a. I'm going to remember that the longest side is always c, which is our hypotenuse. So it makes sense that I'm taking away the shorter side of our longest side, the hypotenuse. Otherwise, I will get a negative number. So it makes sense what I got here, and therefore I can square root this to find the size of a. Don't worry if this is getting confusing. We're going to do some examples that are going to clarify that, but I just want to finish with all the theory before we go into some examples. And in the same way, if I had to find b, and if I follow exactly the same process that I just did, I can also write that b squared is equal to c squared, take away a squared. Okay? Perfect. I told you that I can't draw for my life. Fantastic. Let's continue with some examples.